What's up everybody, welcome back. So today we're going to continue working on our guard and we're going to make sure that he can take cover and then step out of the cover location and fire at us. And before we're going to look into that, I want to look at a few other things, small things that we can do first after the changes we made in the previous video. So this is where we should have left off. The guard can fire at us. And depending on the settings in the data asset, he will keep firing or fire once or fire twice, things like that. So this is the rocket launcher. Let's change it to the rifle. So I'm going to select the guard and then select a different weapon over here. And for example, we have the rifle set to an automatic burst because that was easier when we were testing. And at this point, we can make sure that the data asset actually reflects what we want the weapon to do. So we can make this a fully automatic rifle, for example. So we're going to take a look at the weapons data folder, and I'm going to open up the rifle data asset. So in here, I'm going to make the auto fire true, but remove the burst delay. So it's no longer a burst weapon. And then that should do it for the rifle. And for example, for the rocket launcher, we also have auto fire set to true, so we can disable that stuff. And now it will take the fire time into account. So right now the fire time is 2 seconds and it will fire once, taking 2 seconds to make that shot and then go back into cover. So we can open up the shotgun as well. This is also set to auto fire, so I'm also going to disable that one, and for the sniper rifle as well. And we have all of these fire times pretty high. So for example, the sniper, we could say 1 second, and the shotgun we have 1.5, that's fine. Rocket launcher 2, so there's a little bit of difference in there. So right now, if I would test with the rifle again, you will see it actually keeps auto firing for 2 seconds. Like so. And we can make changes to that if we want to, if we go into the actual guard blueprint. At the bottom we have our AI attack player event from the interface, and over here we are looking if it's an auto fire or not. So currently I have it set to a hard value of 2 seconds. You can make this a random value, or you could choose to add a value into the data assets and then get it from your weapon component over here and simply plug it into the delay if you want to have different fire times for different weapons. And if it's not an auto fire, then it will simply wait for the firing to be done and then continue. So it will basically fire once. And again, you can make changes to that in the data asset and set it up the way you would like to. So for example, if I grab my shotgun right now, over here, the guard, give him a shotgun, then he will simply fire once, and that will take 1.5 seconds, and then he will go back to non-aiming and loop again. So that's how that works. So you don't have to have all of the weapons set to auto fire anymore. That was just because we were testing. Okay, so that's the data assets out of the way. Now I want to make sure that we make a few small changes to the level. So we have a bit more cover locations for the AI to actually take cover. So first of all, let's get rid of this stuff. And then I'm just going to grab this cube. Let's get rid of this one as well. And I'm going to duplicate it a few times. So we simply have a few different locations for the AI to take cover, so it's easier for us to do some testing and see the AI moving around and shooting at us. Something like that should do fine. Okay. So let's save that as well. And now there's one small thing left to do. If we go to the AI guard folder, open up the controller. In here, in the start combat event or start combat state event, we actually have it set up to assign the spotted actor and set focus to the spotted actor. Currently we're not using the spotted actor anymore inside of the actual combat state, so we can get rid of these nodes. and simply plug it into the set value as enum where we set the state to combat state, and that should do fine. So we don't actually need the spotted actor input in here anymore either, so we can get rid of that. And then we want to go over here where we see the red pin appear, and we can simply disconnect that as well. Okay, so that should be good to go. So now it's a little bit less confusing because we're not using that anyway inside of the combat state. There we go. Okay, so let's take a look at setting up taking cover for the AI. First thing we want to do is dive into our blackboard over here, and we're going to add two new variables in here. The first one is a boolean, and that's called isInCover. And the second one is the cover location, so that's a vector, and that's the cover location. And with those two in place, we need to set up an EQS so we can actually find a spot to take cover. So we're going to go to the EQS folder and create an environmental query. So right click, artificial intelligence, and then environment query. So let's call this EQ find cover and open it up. The first thing we're going to do is create a pathing grid. So we're going to drag off the root, and we're going to make points in the pathing grid. So we actually want to be able to reach the points. So there's no use in first creating a grid and then filtering out the points we can reach. We can simply select the pathing grid and make a few adjustments in here. So you want to make sure you actually have enough items in your level. So depending on the size of your level, you may want to spread them out a little bit more or make the grid a bit bigger. But keep in mind, if you have a ton of AI and also big grids, that will take up more resources. So keep it reasonable. So I'm going to set the half grid size to 1500 and then the space in between 100. And we're going to do a navigation trace, but that's fine. We don't really need to change anything in here. The only thing I want to change is the post projection vertical offset. So we're going to raise the points off the ground a little bit by 40 units. So they're not stuck inside of the ground. And what we could do is open up a viewport and then assign our environmental query to the testing actor. So let's see if I can squeeze all of this in one screen. Let me see. So I don't have the testing pawn in the level yet. So first of all, let's do that. Go back to the viewport. Drag in our EQS testing pawn, just drop it somewhere, it doesn't really matter. And then in the details panel on the side, with the pawn selected, we can assign the query template. So let's select our new find cover, and then you should see the grid appear. So this is pretty big for the level that I'm using, but in this case, I don't have a lot of AI in here, so that's okay. Again, you might want to size it down a little bit, but you also want to make sure you actually have some results from the EQS. So just figure it out according to the size of your level and how it's set up, what works best. Let's see. So we want to change a few things, maybe draw filled items. We're going to turn that off. And then we're going to query mode. No, that's fine. This should be pretty good. So let's work with this for now. And let's get our environmental query back up in here. So we need to add some tests. The first thing I'm going to do, right click, add a test, and that's an overlap test. So over here, overlap. And I'm going to use a sphere. So select the test. And we want to set it to filter only. So we're not going to score these items. And we want to change the shape to a sphere. And then I'm going to make the sphere a radius of 120. So let's see, a radius of 100. and then an offset of 120, so it doesn't collide with the floor, but only with actual geometry in the level. And then we want to make sure that we skip our querier, so skip overlap querier, let's turn that one on. And now you can see we're only selecting points that are close to geometry, so where we can actually take cover behind. Currently it's also picking the walls, but we're going to filter those out in a little bit. So that's the first test. Then we're going to trace to the players because we want to be able to, no, sorry, we don't want to be able to hit the players from the cover. We want to be able, I'm sorry, we want to make sure that we are not seen by the player if we're behind cover. So we need a context that actually tells us what all the players are, and I'm pretty sure we don't have that yet. No, we only have the spotted actor context. So let's make sure that we set that one up as well. Let me grab my example in here. And so we want to go back to the context browser, right click, create a new blueprint class, and we're going to look for context. We want to create a blueprint-based environmental query context. Select this one. And this is going to be environmental query. Really, that was an autosave, I think. So environmental query underscore C for context. And then all player actors. So we simply want to get all of the players in the level. So let's open this one up. And we can make it a bit bigger for now. We're going to override and we're going to say provide an actor set. So that's an array of actors. And then we simply want to get all actors of class. And in my case, that's the third person character. So these are the player characters in your project. And then plug in the resulting actor set like so. Compile and save that. And now we can go back to our environmental query. And in here, we're going to add another test. So add test. And I want to go back to my notes in here. So this is a trace test. And we don't want to trace to the querier. We want to trace to the environmental context, all player actors. So select that one from the drop-down list. And then we're going to say require hit. So that means we're actually colliding with geometry. So if we cannot trace to the player, then he should not be able to see it. And we want to make sure that we actually offset the height. So in here, the item height offset, we're going to set it to 90 and then the context height as well. Like so. And then we also want to set these to filter only. And let me see. Only blocking hits, that's good. Visibility channel, that should work. And then we want to hit. So it's actually not filtering them out, but maybe we have to, yeah, so you have to move the EQS actor so it actually updates. And then it should filter out the points where the player cannot see us. I'm not sure why these points are actually in here right now. Let me double check. Is this a third person character? It should be. Oh, that's a guard. Sorry. So obviously we only have a player start in the level and not a third person character. So I was confused. This was not a player character. So let's make sure that he's back at the guard spot over here. And then we also want to drop in a third person character into the level. So our environmental query actually works. So let's put that one over here for now. And then go back in here. So now if we select our actor, the EQS actor, and move him around, he will actually filter out the points where the player can see us. So we can take cover behind this box, however you want to call it. So as you can see, if the trace hit some geometry, those will be valid locations to take cover. So that's the second test. And then we want to do some distance testing. So I'm going to right click again, add a test, and we're going to do distance. So I want to check the distance again to all player actors. So over here, the context, we're going to change it to the all player actors. And in this case, we want to filter and score, so that's fine. And then we're going to set the filter type to minimum. So I want to be minimal range of 300 units away from our player, so we're not taking cover right in front of him. We keep a little bit of distance, and then we're also going to say prefer lesser. So over here, we're going to change the scoring equation from linear to inverse linear. So right now you can see prefer greater over here. If you change it around, it will say prefer lesser. So we want to be at least 300 units away, but we also don't want to be miles away. So this will make sure that we pick a location somewhat close to the player. And we're actually going to make sure that this weighs a little bit heavier than our other tests. So we're going to set the scoring factor over here to 2. And then we're going to add a second distance test. So add test distance again. And this time we want to check the distance to other guards, so other AI, so they don't bunch up as much, but actually have a little bit of distance in between them, and not all of the AI go sit behind the same block, for example. So select this one, and again we're gonna need a new environmental query context that will tell us what the other AI is. So let's move this out of the way and go back to our behavior EQS folder. So we can duplicate the context for all player actors. And let's call this one all other AI. And open it up. And let me grab my example. So again, we want to get all actors of class, but we want to remove ourselves. So what we can do over here, it should have the previous one in here, so provide actor set. We're gonna get all of our BP guards, so get all actors of class and select the GDR guard. And then we're gonna create an array, and that can actually be a local variable. That should be fine, so let's call this one all other AI. And we're simply going to store them as an actor. So not a GDR guard, but simply an actor. And make it an array. We're going to set this array over here. And then remove ourselves from it. So drag off the array, remove item. And we can simply plug in our querying querier actor over here. So we remove ourselves from the array, plug it in, and then plug in the all other AI array over here. So now we have an array with all of the other guards in the level that we can test the distance to as well. So let's go back to our environmental query. So the last distance test, we're going to change the context to all other AI. And in this case, where's my example? Over here. So again, we want to say at least a certain amount. So we're going to change the filter type to minimum again. And this time, let's make it a little bit smaller. So I'm going to say at least 150 units. But we're going to prefer greater. So we're going to keep the linear scoring. That's fine. And I'm also going to keep the scoring factor to 1. So it doesn't weigh as heavy as the other one. And then the last thing we want to do is add a distance test to the querier. So that's the actual AI that want to take cover. And we want to make sure that we take a cover location that's pretty close to us. So we're not going to run through the entire level to take cover really far away, but prefer a location closer to ourselves. So again, add a test, a distance test, distance to querier, that's fine. And this time we're only going to score. And we're simply going to say prefer lesser. So we're going to change it to inverse linear. And that should pretty much do it. So right now you can see, I think this one over here is the highest score, 2.34. So the AI will take cover over here, and if I move him more over here, then this point will be higher up because this is closer than this location. So this way we can play around with it a little bit. Right now it will pick this location, or sorry, this location, because this is a little bit closer to the player. So that way, that's how it works, pretty much. So let's save this find cover query for now, and we can close it down. And let's get rid of the viewport as well, and we want to open up our behavior tree. And I need to get my notes in here again. So the last time we added our combat state, so that's over here. And what we want to do after the player to attack, so after this section right before the wait, we're simply going to move this to the right a little bit. And in here we're going to create a new sequence. So we're going to drag off, add a composite, and that's a sequence. And we want to add a blackboard based condition, so right click, add a decorator and blackboard. And we want to make sure that our cover location, is in cover boolean is not set. So we're going to select the is in cover boolean and change this one over here to is not set. So if we don't have a cover location at this point, we're going to look for cover. And we're going to do that by running an EQS query. So we're going to drag off here, task, and then run EQS query. In here we want to assign the query that we just created, so find cover, and we're going to set the blackboard key over here. So we're going to store the result of the EQS query inside of the cover location. So select that one. And then we probably okay, we could change this over here. So right now we're simply going to pick the single best item, so the one item with the highest score. You could randomize it a little bit if you want to say, well, pick a random item from the items with the 5% of the highest score, something like that. So make it a little bit more random instead of simply choosing the highest scoring item, but it doesn't really matter for the outcome. So let's keep this one. Now, what we want to do is make sure that our cover location is set. Let me double check. Oh, no, I'm sorry. I'm looking at the wrong part of my notes. So over here, we need to move this a little bit over here. We're going to add a decorator over here. And again, we want to make sure that the cover location is not set. So over here, we're going to look for the blackboard based condition, select it. Cover location is not set. So if we are not in cover and we don't have a cover location, we're going to run this EQS query. And we want to make sure this actually forces success as well. So we're going to right click, add a decorator, and then choose force success. So that way, if we don't find a cover location, we still remain inside of this sequence. That's not important for now, but it will be later. If we actually have a cover location, we're going to go over here, add a task, and that's a simple move to task. And we want to move to the cover location. So select the node and then select the cover location in here. Okay, that's the first part of the behavior tree. So I think right now, yeah, we should be able to do a quick test. So let's see if we grab our viewport. We might want to get rid of the EQS actor, so simply delete that one and also delete the third person character over here. Oh, that was the card, my bad. Delete the third person character. And then we're going to hit play. Now let's see if the AI is attacking. So first he's going to shoot at us, and then he's going to find a cover location. So he's going to take cover behind that wall. And at this point, nothing actually will happen anymore unless the AI sees us. So if we remain over here, he's not going to do anything. But this should work. So for this part, this should happen. Okay. So that's good. Now, again, we want to go back to our blackboard and we want to add an attack location to it. So if we're in cover, we need to be able to step out of the cover and then attack the player. So we need a location where we can do that from. So first of all, let's open our blackboard. And again, we're going to add a new key, and that's a vector. And this is going to be our attack location. And we also want to create a behavior tree task. So let's minimize this, go to the behavior tree tasks. And we can pretty much duplicate one, that doesn't really matter. So behavior tree task. And then I'm going to say set is in cover. Then open it up. And I need to grab my notes again. So there's a lot of going back and forward. I'm sorry, bear with me. Over here. So we have the event receive execute AI. That's fine. Let's get rid of this stuff for now. So we do want to get our blackboard. So drag off the control pawn, get the blackboard. And then we want to set our is in cover boolean. So over here, we're going to drag off and set a value as bool. Plug it in over here. The key name is going to be the boolean is in cover. So we're going to make a literal name. And then make sure you type in is in cover exactly in the same way as you have it set up on your blackboard. So this boolean over here. And we want to set it to the new cover state. So we're going to create a new variable. Make this our new cover state. And we want to make sure that this is instance editable, I think. Let me double check. Yes. So we're going to select the bool over here. On the right side, we're going to say instance editable. And then we want to plug it in over here into the new bool. And then we're going to add a branch in here. Plug in the new cover state as well. And if we are not in cover, we want to clear our attack location. So then we're going to again set a value on our blackboard, but this time get rid of it. So we can say clear value, make a literal name again. And we're going to clear our attack location. So this goes into the false bin, and if we are in cover, we're not going to do anything. So we're simply going to drag up the true bin and then go with a finish execute. So we have to make sure that we finish with success to make sure that we stay inside of the sequence in our behavior tree. So a sequence actually stops executing if one of the children fails, and these tasks, these successes, is what reflected. So we want to make sure that we set this one to success. And again, the attack location refers to the blackboard key that we just added over here. So make sure this is spelled correctly. And this should be our task. So because we have this bool set to instance editable, we can change it in our behavior tree if we drag in the node. So we're going to go to the behavior tree right now, and we're going to add a little bit in here. After the move to cover location, drag off, and we're going to set a task, and that's our set is in cover task. So with this node selected, we can set the new cover state, and we want to set it to true, because at this point, if we moved to the cover location and this was successful, then it's going to execute the next node and it will set the is in cover bool to true. If the move is not successful, then the sequence will abort, so it will never reach this node. So that's good to go. And then let me see. At this point, we want to go to the beginning of our sequence. So we're going to go to the current state is equal to combat. First thing we do is change the move speed. And after that, we want to add a sequence again. So we want to make a little bit of room over here. Drag off. We're going to add a composite sequence. And the first thing we're going to do is check our is in cover boolean. So we're going to right click, add a decorator blackboard based condition. Select this one, check our is in cover boolean, and we want to make sure that it is set. So in the case of a bool, that means if is in cover is true. And again, we also want to force success over here. So we're going to add a decorator force success. And then what we want to do is actually set our is in cover boolean back to false. So we're going to drag off here, go to the task, and go to our behavior tree task set is in cover. And the new state is going to be false. So basically, one loop in here represents taking cover, stepping out of cover, attacking the player, and then go back to the beginning. So at this point, we want to look for a new cover location or go back to our original cover location. And to make sure that works, we want to set this bool to false over here. That's just simply how the logic works in this case. So now we want to create an EQS query where we can check a location that we can step out of cover and attack the player. So if we actually have a valid location to attack enemy. Let me see. So I'm going to open up the query inside of my example project. And we want to go back to our EQS folder again. Right click, create a new environmental query. So let's call this environment query can attack from nearby. Open it up. And again, we want to add a pathing grid. So we're going to drag off the root, create a pathing grid. And this could be a little bit smaller because we don't want to walk out of cover and then walk miles before we attack. So if we don't have a location that's relatively close to us, we won't be able to attack, essentially. So let's make this 700. You can make it a little bit smaller even if you want to. The space in between, I'm going to keep 100, that's fine. And again, I'm going to set the vertical offset to 40, so the items appear a little bit off the ground. Then we want to add an overlap check again for the capsule. Or a sphere, that doesn't really matter to be honest, but I'm going to say capsule, and we want to make sure that we don't hit something with that. So we're going to right click, add a test overlap. Select the test over here. Let's change it to capsule because the actual, how do you say it, characters also use a capsule in game. So we can represent the size somewhat, but we're going to make it a little bit wider than the actual character capsule. So if we step out of cover, we're not really close to some geometry, but we actually want to have some clearance. So that not only our elbow and our gun sticks out, but the player can actually see the entire AI that is attacking him. So we're going to set the extent 120, an autosave again. And then the height is going to be 90. We want to set the shape offset, the z-axis, to about 110, so it's not colliding with the floor. And this case, we want to say don't match. So we don't want to hit any geometry. And we could actually plug in our testing pawn again to visualize this stuff. So let's do that. Let's grab our viewport. This is a bit annoying on one monitor. So the EQS testing pawn. So this query will be called when the guard is actually in cover. So let's put him behind something like that. We're gonna assign our query, so can attack from nearby. And then let's disable the draw field items so it actually looks a little bit easier to spot what he's doing. And again, we also want to add a third person character in here to make sure it actually works. So that represents the player. So we're going to put the player over here, for example. So it's actually a valid cover location from our previous query. Okay, let's go in here. So if we select the environmental query actor, you see he won't pick any locations that are really close to a geometry, so he will actually step out of cover a little bit and have a bit of clearance, so that will feel more fair for the player. So if the AI would stand over here and you can only see half the AI, that's a bit annoying for the players. So he will actually step out and then have some clearance to geometry. So you can increase the capsule width if you want more clearance, for example. As you can see, then more points will be removed. So let's keep it at 120 about. That should be okay. Then we're going to add a trace test. So again, right click, add test, and we're going to trace. And we want to trace to the player characters. So we're going to say all player characters. That's the context that we created earlier. So the context over here, drop down list, all player actors. Trace on the visibility channel, that's fine. Let's see. Oh, yeah, that's fine, visibility, but we want to change the trace shape from a line to a sphere. So let's select sphere, and we're going to make the sphere 45 units wide. So again, this will make sure that we will have a bit of clearance. If we use a line trace, we can shoot really close past geometry and it could hit the player. And again, that could make it that the AI is just barely visible for the player. So we want to create some clearance. So that's why we use a sphere trace with a 45 radius. And then we want to make sure that we actually can hit the player, and that means that we don't hit anything else. So over here it says require hit. That can be a little bit confusing, but because you want to be able to hit the player actor, but you actually want to change it to false. So that means the trace doesn't hit anything and it will complete the entire trace to the character. And then we also have a valid location to shoot from. So make sure you change the bool match to that. And then over here, if we go to the advanced section, we have a multiple context score. And because our context is an array, we want to change this over here. So we actually want to make sure that any of, over here, my bad. So for the scoring, it doesn't matter because we're only going to filter anyway. So we want to set this to filter only. And then for the filter over here, we have the multiple context as well. And in this case, it's set all pass. So that means if we have two players in the level, then the trace would need to be complete to both of the players for this item to pass. But that's not really relevant because if we can hit one player, then we can attack that player. So we want to change all pass to any pass. So as you can see, more items will be valid now because over here we can hit this player but not this player, for example. So that's what this means. Make sure set it to any pass. And that should be the trace. Now let's do a distance check again. So we're going to right click, add test distance. We're going to set the distance to all the players again. So the context is going to be all player actors. And in this case, we don't want to filter, we just want to score. So we're going to change it to score only. And we want to be, we don't want to be too close. So we're going to say prefer greater and actually leave the scoring factor to 1. So this should do for the distance test. And then we're going to add a second distance test to the querier. So that's the guard that actually queries the environmental query. And we want to take a location that is close to the querier. So again, we're going to say score only. And this time we want to inverse linear. So we prefer lesser. And we could make this way a little bit heavier. So let's say 1.5, for example. So now we're going to pick a location that is close to ourselves, but relatively further away from the players. So as you can see, it would pick something over here to 91. So we're going to step out of cover, fire at this player, and then we can later go back into cover again over here. So as you can see, these tests are not really too complicated. As you can say, you can add multiple things in here, make it more complex, but then you will also result with less items that are valid, and that could make everything get stuck basically. So if the AI doesn't have a place to attack from, then he will get stuck in some weird loop, for example. So you also always want to make sure that you don't overdo this and end up with only 1 or 2 results, and then in an actual level where you're playing, it might not give any results at all. So this looks complicated, but it's really not too complicated. And this should work fine. So we have our can attack from nearby query set up. And now we want to go back to our behavior tree to actually implement this. So let's go back to a big screen again over here. And I'm going to switch my nodes. So after here, we have the set in cover to false. This is forced success. So no matter what happens in here, we won't break out of the sequence. Now we're going to drag over here. We're going to run an EQS query again. So task run EQS query. And we're going to run our can attack from nearby. And this time we want to store the result of the query inside of the attack location. So make sure you select attack location for the blackboard key. And again, you could change the single best item to a random one, but in this case it might be best to keep the single best item because that's the item closest to the AI, so that will look more natural when he's stepping out of cover. So this should set the attack location if it actually finds a valid one. So let's make a little bit more room over here. Do we need to do something? Let me double check my notes quickly. Yes, so let me explain a little bit. So over here we looked for a location where we're going to attack from, but we don't actually know what player we are going to attack at this point, and that's something we want to know before we actually tell the AI to attack, because that way we can set focus to that player and then strafe out of cover. So if we don't have focus set to a player, the AI will not strafe, so he won't sidestep, and then he will simply walk out of cover, then turn around and then shoot, and then turn back around and go back into cover. So that looks a bit weird and unnatural. So we want to be able to strafe. And like I mentioned, to do that at this point, before we actually go into attacking, we want to make sure that we know what player we are going to attack. And again, for that, we're going to use an environmental query. So I'm going to grab my notes. And we want to create a new environmental query again. So let's close this down. Now we can get rid of this. And make sure we delete the third-person characters as well. Let's make sure we save it in case something horrible happens to Unreal. So let's right click again, and we're going to create a new query, and we're going to call this one, let's see, attack location. We already did that, so we want to say, oh well, let's make our lives a little bit easier. So I'm sorry, I'm going to delete the new query over here. We can actually duplicate our can attack query over here. So select this one and duplicate it, and we're going to call this one attack player from location. So EQ attack player from location. And we need to feed in the attack location that we got from the previous query. So over here, we are not going to generate a grid. No, we're not going to generate a grid, but so inside of this query, we want to know the location that we stepped out of from cover where we are at that point to see what players we can attack. So we need that player as a result from this query. So we're going to need a context again that will tell us what that attack location is on our query. So let's create a new blueprint class, look for context. I'm sorry if this sounds a bit confusing, but I'm gonna explain it if we have it set up, so that way it should make a little bit more sense. So we're gonna call this our environmental query context attack location. Open it up. And this is not too complicated, but again, I'm gonna grab my notes to make sure I don't mess up. So let me get my attack location. We want to grab our provide single location. So override provide single location over here. And then the querier is the guard. So we can drag off the actor from the guard and get the blackboard. And we simply want to get the blackboard key attack location. So we're going to say get a value as vector. We want to make a literal name. And that's our attack location. So again, this refers to the blackboard variable we set up over here. So it should match this exactly to make sure that we actually find something. And then we can simply plug that into the result of the context. So we have that one set up, compile and save. And now we can go to our attack player from location query. And in here, we want to change the querier with the attack location. So what we actually want to do, okay, let me see over here. That was a little bit of Dutch. So generate a set of actors of BP third person character around querier. That's okay. But then we want to trace from the attack location instead of from the querier. So we're going to select the trace and we're going to select our attack location over here. And for the distance, we want to do the same thing. So select the distance. We're not going to check the distance to the querier, but to the attack location. And for the last one, we can change the dot as well. So we're not going to change the take the querier rotation, but we're going to change this to 2 points as well. So we have line A. Currently it's using the rotation of the guard, but we're going to change it to 2 points. And then we're going to make a line from the attack location to the item. So attack location to item. And we're going to compare that with the rotation or line from the querier to the item. So that way we're going to try to attack in the same way that we are currently facing, instead of turning around 180 degrees, for example. He could still do that, but he will prefer players that are already in front of him, basically. So that's all we need to do for this query. Let's save it and close it down. And then we can go back to our behavior tree again. So in here, and grab my notes as well. So we have the query that chooses our attack location. If this succeeds and finds a location, then our attack location on the blackboard will be set. So then we can use that. So we're going to drag off here. We're going to add a new task, and that's again an EQS query. But we're going to add a decorator over here, blackboard based condition. And we want to make sure that we only execute this if our attack location is set. So we're going to say attack location is set. Select the query, and we want to use our attack player from location query. And the result is going to be an actor this time. So we want to store the result in our player to attack over here. So the query, that's not this query. Where were we? Over here. I can double click this. So it generates a set of actors in this case. So we won't get a result that's a location, but we get a result that's an actor. And because of that, we can store it in the player to attack. The player to attack is an actor as well, an object, but that's set to an actor type. So that way we can store the result from the query in there. So the result can be either a location or an object slash actor. Okay, so if we have that, then we can drag off here again, and we can say that we want our AI to rotate towards that player. So we already have a task for that, AI rotate towards. We're going to do that over here. And we're going to say use actor rotation. And then the actor that we want to rotate towards is the player to attack. That's over here. So this will make sure the AI faces the player. And then we probably need to create a new task. Yes, so we want to create a task that will actually set the focus for us. And also, because we want to be able to strafe, we need to change a setting on the character movement component. So that's what we're going to do over here. So we're going to need a little bit more room again. Nope. No, really. Select everything, drag it to the right. And then let's go to our task folder, behavior tree task. And we could simply duplicate one of these, that doesn't really matter. And we're going to say set rotation and focus. Yep. So we're going to use the receive execute AI, that's fine. Let's get rid of the rest. Now it will give a pawn over here, and we actually want a character because a character has a character movement by default, so we can access that component. So we're going to drag off the pawn and cast to a character. So we're not going to cast to the actual guard class. We're going to keep it as light as possible. From the character, we're going to drag off and we're going to get the movement component. So that's all the way down in the list. The actual movement component over here. Oh, sorry. It would actually be better if we say get character movement, because that's what it called, and then you will actually get the variable type over here. So character movement. And from here, we want to drag off and set orient rotation to movement. So set orient rotation to movement. This one. Plug it in over here. And we want to turn this into a variable. So we're going to drag off, promote to variable, and let's call this use default rotation. And we want to make this one instance editable again, so we can change it in the behavior tree according to what we need. So we're going to select this over here, select instance editable. And let me quickly show. So this actually refers to our guard character. We have the character movement component over here. And this is simply a setting on the movement component that's already in here by default. Let me see over here. So the rotation, currently we have that set to true, but if we keep this enabled, the AI guard is not able to strafe. So we want to make sure we disable this if we want to be able to make strafe movement. So that's what we're doing over here. Then we're going to grab a branch and plug in the result from the default rotation. So if we are using default rotation, that means we're not actually attacking, and then we want to clear the focus from the AI. So we're going to drag off the controller and we can say clear focus. And if we actually have this enabled, that means we are in cover and we want to be able to strafe. And because of that, it also means that we want to keep focus on an actor. So then we're going to say set focus. Plug this one into the false pin. And we want to actually set focus to the player to attack. And we have that stored on our blackboard again. So we can drag off the control on and get the blackboard. From the blackboard, we can get a value as object. And that's the literal name. So we want to get our player to attack. So make sure you put in capitals and things like that exactly the way they are on the blackboard. So this returns an object, so we need to cast it to an actor to be able to plug it in over here. So we're going to say cast to actor, and we can turn it into a pure cast because we are pretty certain that's an actor, because on our blackboard we actually have it set up as an actor type. So if we go over here, player to attack, the base class is actor, so we are sure it's an actor, so we can use a pure cast and then plug it in over here. So that's the task we're going to use. We're going to finish execute again, and to make sure we stay inside of our sequence, we want to execute with a success. Compile this and save it. And now we can go back to our blackboard again. So let's go to the blackboard, behavior tree. And I'm going to grab my notes. So we want to set the rotation and focus over here. Drag off, add a task, rotation and focus. And in this case, we're not going to use default rotation. So we're going to use our strafing rotation. That's not the default movement for our guard. So we're going to disable this, keep it false. And then we can move to our attack location. So drag off here, task, move to, and with the node selected, we're going to change the key to our attack location, like so. Then the next node that was already in here. So if we move to the attack location and we have a player to attack, so this is not set, this is set, then we're going to attack the player. And then if is in cover is not set, and it's not set because we cleared it over here, then we're going to look for cover again, go back into cover, go to the beginning of the sequence, and then do the whole thing again. So that's how it quote unquote is going to work, but we're not done yet. I'm going to tell you that right now, but we can have a quick test. So let's see. Let's go in the level, make sure the AI is in combat. So he's going to shoot at us, and then he's going to look for cover. Sort of. Good enough for me. And then he's going to step out of cover, fire at us, and go back into cover. And if we move to a new location, then he's probably not going to look for a new cover location. Oh, he is actually. Well, we're going to refine this a little bit, so don't worry. No, he's not going to look for a new cover location. He's simply going to stay there. But this is a beginning, so he's now actually stepping outside of cover and then fires at the player and does a little bit of logic over there. Now what we want to do, basically it's not really needed, but I think it makes a little bit more sense. So as I mentioned, at the end of this, the AI is going to look for a new cover location, but if we are already in cover and that cover is valid, then it makes more sense to step out of cover, fire, and then go back to the same location if that's still a valid cover location. So that's a little part we're going to add right now. And then we should pretty much be good to go. So again, we're going to need an environmental query context for that. So we can actually feed in our current cover location into an environmental query. So let's go to the EQS. We're going to create a new class. Again, look for context. Select the blueprint based one, create it. And this is going to be our environmental query context cover location. Open it up, and I'm pretty sure we just want to grab the cover location from the blackboard and feed it in, but I'm going to make sure. So I'm going to open my notes. We want to provide a single location over here. And then indeed, we're going to drag off the actor, get the blackboard, and get the cover location from there. So let's get blackboard, get a value as vector. And then we can make a literal name. And that's going to be our cover location, and then we can simply feed it into the return node. So then inside of an environmental query, we can use our cover location. And we're going to make an environmental query, and that's going to be called check our current cover. So let's go back to the folder over here, right click, artificial intelligence query, EQ, check current cover, and open it up. There's a capital too much, but that doesn't really matter. So let me grab my notes in here. Well, we could make our life a little bit easier again if we simply duplicate an existing one. I'm sorry. So let's get rid of the new one we created, and I'm simply going to duplicate our find cover. So over here, the query find cover, duplicate it, call this check current cover. And then what we want to do in here, the current location of our cover location. So let's drag this to the side. We're gonna drag off here, and we're simply gonna use a current location. Select this one, and for the context, that's going to be the cover location context we just created. So select this one over here. And then all we want to do is drag over our sphere test, and we're going to drag over our trace test. So we're not going to worry too much about the distance. Those should be fine. We simply want to know if this is still a valid cover location where the player cannot see it. So that's pretty much all we're going to do. Let's get rid of this stuff. And that should be good to go. So now we can save this one, close it back down, and go back to our behavior tree. And then the last thing we want to add inside of our behavior tree is going to be over here when is in cover is not set. So after we attack the player, and is in cover is not set because we changed it to false over here in the beginning of the sequence. So this will always fire after we attack the player. We want to make sure that we check the current cover location that we have stored. And if that's not valid, we're going to look for new cover. If it's valid, we're going to go back to the cover location we already had. So we're going to drag off here. We're going to run an EQS query. And that's going to be check current cover. So select it over here, check current cover. And we're going to store the result inside of the cover location. So select the cover location over here. And we want to make sure that our cover location is actually set when we do this. So we're going to go to decorator blackboard, select the decorator and select our cover location. Make sure it is set. And we also want to force success again. So we're actually not breaking out of this sequence if this fails. So force success and the condition. And then in the next node, we're going to say if cover location is not set. So basically, if this query fails, if one of the tests in there fail because they are set to filter, no, I can go in here. So if I double click over here, so both of these are set to filter only. So if the test failed, then the item will be removed and there will be no result inside of the cover location key on the blackboard. So that means we need to look for a new cover location. So in that case, we're going to drag off here. And we want to clear our focus and rotation because then we don't want to strafe anymore, but we want to run to a new cover location. So we're going to go to task and then set rotation and focus. We're going to use default rotation. So in here, enable default. And we want to add a decorator blackboard. Make sure that our cover location is not set. Cover location is not set. And again, for this one, we want to force success as well. So select it over here. So a force success node is pretty useful if you want to have multiple branches inside of a sequence that either follow up each other or that you can make a selection between without breaking out of the sequence. So this should pretty much do it. And then over here, so let me try and explain. So after we attack the player, we're going to check our cover location that is stored on the blackboard, if we have that, but the location should still be set, because we're only clearing the bool over here, not the location. But the first time we actually run into this loop, it's obviously not set because we haven't been in cover yet. But imagine we have a cover location that we're gonna check our current cover. If this query fails, the cover location will be empty, so this key will be cleared, and that will make sure that this node fires. So the cover location is not set. We're gonna set the default rotation. And then again, if the cover location is not set, we're going to look for a new cover location and then move to that one and set our is in cover bool to true. And then we're going to go back to the beginning of this sequence because we're still in combat and we're not in idle or searching or chasing, so we don't need to worry about the other nodes. And then at the beginning of the sequence, we're going to make sure that our new cover state is false. And then check if we can attack from a nearby location. If we can attack from a nearby location, we're going to set the focus, move to that location, and then attack. So that's pretty much the loop that we are going through. And currently this should pretty much work. So if we go into the level and, for example, make sure we are in combat, then the AI is going to fire at us and then look for a cover location. That's a little bit lame, to be honest. I thought I had that smoothed out a little bit. So I'm going to check to make sure that he's not going to pick a location like that anymore, but I'm going to do that in a second. So I want him to move a bit further behind cover and not actually be outside of cover with half of his body like he is now. So that's something I'm going to take a look at because I probably just forgot something over inside of a query. But other than that, it's pretty good. And if we are over here, so our cover location is not valid anymore, he's going to look for a new cover location. So yeah, that's it's not really sophisticated behavior, but it works, and you can expand on this and play around with it. And this also works with multiple players, although that's a little bit harder to show, but this will actually work. And also, if you have multiple AI in the level, they will all do their own thing. So yeah, like I mentioned, not really sophisticated, but it works. And you have something to check out how your blackboard works, how your behavior tree works, how you can use environmental queries, things like that. So yeah, that's pretty much it. Let me quickly double check to see if I can make the AI move a bit further behind cover, so I'll be back in a second. Okay, I'm back. It turns out I do have it set up the way I want to, and I don't think there's a really easy way to prevent it with the EQS system. So what basically happens, it's going to trace from the center of this item to the player character. And we have it set up as a line trace, so that's the smallest trace possible. But obviously the actual AI will have a bigger radius than the line trace, so the AI character can stick out of a corner a bit. What you could do, for example, is increase the grid size for the query. So this is the wrong query. So you want to space out the points a little bit more. Let me see. And then there's less chance that they actually end up at the corner of one of the geometries. But still, it also depends on where the actual AI is, depending on where the items will appear. So it's kind of difficult to prevent it with the way we have it set up, and also with an environmental query in general. You can also see there's quite a lot of points in here, to be honest. You might want to size down the grid a little bit, or as I mentioned, make them space out a bit more. So you won't end up with a very intense query if you have a lot of AI in the level. what you could do, for example, to overcome this, but then it requires a little bit more setup. You can make an actor that's a cover location for the AI. So simply an empty actor over here with a billboard so you can see where you place it, and that's going to be a potential cover location. Then in your level you want to place those around geometry, but then you can make sure they're not too close to the edges. And then if you set up the actual environmental query, so you don't want to simply generate a pathing grid and then do the testing, but you want to start off with an actors of class and then get all of your cover locations and test against those. So that way it does take more setup to do, but if you want to have more refined combat, then that's a solution you could use. So then if you check with the environmental query, then you will see it filters out the points that player can see, and you will end up with cover locations that aren't really close to the edge. So if you can figure out a query that actually does this for you, then feel free to post it in the Discord or the comments. That's also a nice challenge maybe, but I think it's going to be kind of hard to actually set it up like that. But nonetheless, we do have a kind of functioning system, and it actually isn't that bad if you play it in a level and just play around with it. You will see that you can have decent combat with the AI now. So I'm going to do probably one more episode for this series, and then we're going to go into the behavior tree and make sure that we add some comments to the nodes and things like that, so you know what's happening where, and everything makes a little bit more sense if you want to play around with it yourself. And then we probably also going to add it to the multiplayer project in a separate episode as well. But for today, I want to keep it at this. So thanks for watching, everybody. Hope you enjoyed, and I'll see you next time. Bye bye.